Hi everyone, this is Premanand Tiwari from Amazon, and I'm an applied scientist at Amazon who works in developing forecasting models for capacity planning, inventory planning, and some other few things. Today we are going to talk about AgentCast, an autonomous AI system that I have built that enables our planners, especially who works in capacity planning, and analysts to use autonomous AI system to create forecasting models and deploy them. And we'll talk about forecasting at scale, specifically for DevOps. The DevOps forecasting challenge is in there are some traditional obstacles. Capacity planning requires usually multiple data science expertise, data scientists, planners, operational engineers, and these kind of people are usually very expensive, hard to get hired and to maintain their costs related to the models. And then there is manual model management consumes valuable time usually. For example, if you have to retune since the accuracy is going bad, then you have to go back and do analysis. If there's different types of data that has been added, you have to go back in and do manual analysis. So these are some of the challenges that we see. This static approach fail that evolving infrastructures. For example, you are adding more kube clusters or more containers or more container registries, then you have to make sure that everything is in the line. Performance monitoring lack predictive capabilities, meaning when you are monitoring the performance of your stack, you do not know what is going to happen day from today, day after tomorrow, and so on. So you have to make a system ready to take care of these things. And there is like real operational impact. DevOps team faces constant pressure to predict resources, for example, how much compute they would need to run applications, especially if there are multiple spikes they are anticipating. For example, if there's you are working in a company where you are selling something in a holiday season more, so your traffic will be higher, so preventing that. And then making sure that if you predict your capacities in real time, you are able to scale up very quickly. And basically cost optimization related to infrastructure as well, you can maintain. And you can maintain very complex ML systems, like how much you compute need, how much you need compute for inference, where you want to save your data at. So we are proposing a solution, an autonomous AI forecasting system that you can plug into the database where you have all your data, and it can learn different patterns and do time series forecasting for you. AgentCast, it's a fully autonomous AI agentic based approach where you don't really need any human intervention. You just plug in the agent with the data that you're getting in real time. It could be streaming data, it could be batch data, and it will learn from it, and it will just generate forecasting based on the patterns that it sees. It's DevOps native, so technically you can just plug in and it will do all like predictive planning for you. And it's continuously adaptive, means as soon as you see system is getting more intermittent data or more sparse data, it will adapt to it, and you can scale it to adapt to different type of capacities. For example, if you are writing more data to some drive, it can predict disk usage and memory usage in apps and whatnot. So it's continuously adaptive. It's a comprehensive model toolkit. It has a bunch of machine learning models, deep neural network models. For example, we use temporal fusion transformers, we use NBs, we use LSTM and GRUs, and transformer-based models. So it has whole suite of models because we don't know what kind of data we're going to get in. So agent decides what is the best approach to take based on the data that you are getting. There are machine learning approaches such as XGBoost, and for example, if you have more independent variables, XGBoost kind of model works better where you want to do a very simple forecast, ARIMA or auto ARIMA. A simple Holt Winters can work better. So it has statistical model, machine learning models, and deep learning models, and it picks up based on the data and analysis it performs on the data to see what is the best model to use. Intelligent adaptation in action means it has context-aware intelligence. AgentCast doesn't really rely on pre-trained models because it looks at your data, runs model to do training, hyperparameter tuning, and everything else, finds the best loss metric for you. For example, are you looking for MAE, RSME, or other kind of metric? If you have your custom metric that you want to look at, then it looks at that. It discovers patterns in your application usage, or it discovers patterns in spikes, and it figures out what's noisy, what's actual trend, and based on that it does forecasting. And it does it with pretty good precision as well. It can do multiple forecast horizons as well. For example, if you're planning 1 month out or 6 months out, you just have to change the forecast horizon for the agent, and it will take care of it, figuring out what is the best look back period for this kind of forecast. And it also does probabilistic forecast. So instead of doing point-wise forecast where you're just getting 1 point at a time in time, it does you P10, P50, P70, and P90. So it just gets you a probabilistic distribution rather than just a point forecast. The reason it's also like DevOps centric is because when you're doing probabilistic approach, you can also see how much variance you are expecting in your demand, or what other things you need in the cycle to adjust your forecast. So it gives you different distribution metrics, different level of deciles actually. So it eliminates also like manual hyperparameter, like you don't have to provide a grid search manually and run through different models. It, based on the data, decides a grid search for you, and it has probabilistic methods within the hyperparameter tuning that finds the best hyperparameter tuning based on each iteration. And it's very seamless to integrate into your continuous integration and continuous deployment pipelines. You just have to upload the code of agent and plug in to the current workflow, and it just creates the bells and everything else to run the models. It finds seasonal variances on its own, what's trend, what's noise, what's long range dependencies, and provides forecasts based on your infrastructure needs. It has enterprise grade reliability because you really don't need any manual intervention. It has its autonomous operational capabilities, so it's running on its own, it's performing daily or weekly iterations of training. It checks the WAPE in real time, or ME or RMS in real time, like how the forecasted. And based on that, if it sees deviation from what is the acceptable norm of forecast, it's like creates new training system where it retrains hyperparameter optimization, and then it like creates the final model that is then used for inference. So that's the autonomous operation. As I said, it constantly looks for what's the need of capacities, how much hardware you need, how much infra you need. It does that continuous monitoring and also keeps running different kind of error metrics to figure out that the forecast is not deviating. It's a production ready agent. You just have to plug into your current workflow and it works fine. Versatile forecasting horizon. It can do high frequency monitoring, real time infrastructure metric with sub-minute granularity for immediate operational insights. For example, if you are running a kube cluster where you are running multiple pods, you are upscaling to multiple pods, it can identify that spike in the time series trend, and based on that, it can forecast and tell how much, whether, how long and how much you need your infra to be up. And one of the reasons most of these services on cloud have auto scaling versus what is the need of this is this kind of forecasting system is like auto scaling is typically very expensive. You can enable auto scaling and that might work well for you, but at the end when you get the final bill, it's going to be very expensive. So usage of this kind of system where you are uploading forecasts from this agent into your YAML configurations to get the infrastructure scaling up or down is price wise beneficial, and it reduces cost related to your infra. It also does like long medium term planning. So like it can do how many CPUs or GPUs you need based on the kind of task you're performing, whether it is an app-based system you are running on or you are running an ML-based system. It can do both. Long range capacity, like it can do monthly to quarterly up to 3-year forecast easily based on the pattern that it has seen historically. There are multiple components to AgentCast. First is automatic discovery. Based on the time series data that it reads from the data sources, it does what is the best kind of model for the time series data. If you have a problem where you have multiple independent variables and medium or short-term horizon forecasts, ML-based system like XGBoost or linear model might work best. Where you have a really long-range forecasting need, a temporal fusion transformer or a deep AR-based model that might work because it can easily detect dependencies in the long-range time series. Model evaluation is based on you running multiple models. You are checking mean absolute error, mean absolute percentage error, RMSE, bunch of other metrics. You can also define custom metrics for evaluation, and it finds the best model for it. And a lot of time it can also do ensembling of models, like maybe just not one model works best for you, but combination of 2 or 3 model works for you. It can do ensembling as well and give you the best results, ensuring there is no overfitting to your time series forecasting. It has intelligent selection based on the analysis it performs. It can find the best performance metric, whether RMSE is the best way or some other like MAE is the best. If you want to capture more variance between your time series forecasts, you'll use RMSE, which captures roots, square roots. If you want to do like a point wise forecast, MA is more absolute or MAPE is more absolute. It can figure it out that. Autonomous deployment is it deploys these model into production environment, whatever it finds, whether it is single model or ensemble model, and it also performs continuous evaluation of the model. Based on that, it can do continuous evolution. If you need to rerun hyperparameter tuning, that can be added. If the nature of data changes, it can rerun the whole suite of models to find what is the best model for the newer data. It has real DevOps application from infrastructure monitoring, how your CPU usage or GPU usage will look like, memory usage will look like. If you are expecting more spike, it can predict how much more you need based on more cost optimized manner rather than just doing auto scales. It can also see if you have network, higher traffic, network usage, it can enable potential bottlenecks, failure, and it can give you the right forecast for your infrastructure so that you don't run into potential bottlenecks. Capacity planning, it's long term, so like you can tell within 1 year or 2 year horizon what your infrastructure need would be for different components of your infrastructure. And it can also do like predictive maintenance. So if you are seeing degradation over time, it can do rerun of model, figuring out what's the best model for the latest data. It's built for DevOps scale, so you can do different kind of automated versioning. You can do rollback capabilities. If you're not liking a model, you can roll back. You can disable the inference system. There is A/B testing build, so you can deploy on one system and leave one system without the deployment and see which system is performing better. So you can perform all kind of A/B testing as well. It can do performance monitoring, as I said, like it can do wave monitoring over time of the real-time forecast in the system, and it can tell whether if you're degrading, and it can automatically decide whether it needs to retrain the model or find newer model. It's scalable, so your architecture is like very distributed. Everything from individual microservice to enterprise-wise deployment can be done, whether you are running on a simple application or multi-microservice kind of application. It can be plugged into both the systems. The autonomous advantage is more like you don't really need any human intervention. So you don't need to hire a data scientist or a statistician to run and retrain and figure out what's the best model for your system. It can do on its own. It has its own probabilistic brain that it uses to make decisions. It can reduce operational overhead. So rather than somebody telling, hey, we don't really like this model to the statistician or data scientist. It can decide all those things on its own. So like communication over churn is reduced. That's reducing the operational overhead. Faster time to value means as soon as you deploy the model, it starts generating forecast from quickly like plugging into your system, and that helps you get reduced time from very starting point to getting the forecast that is finally being used to make decisions of your DevOps team. What you'll see today is like autonomous workflow demonstration, watch AgentCast discover, evaluate, and deploy models without human intervention. And this is the expectation of the agent. Some of the examples involve forecasting CPU utilization, memory consumption, network traffic patterns. Are you planning to see spike? So things like if you are expecting higher traffic, load balancer, scale up, scale down, and then the integration walkthrough into the current DevOps pipeline. You can transform your predictive operations with using the AgentCast. The future of DevOps forecasting is enabling based on AI agents that can perform autonomous forecasting without human intervention, so reducing human decision making, human workflows, and it needs to work on its own, figure out bottlenecks, figure out what kind of utilization or capacity are you expecting short term, medium term, and long term, and also do predictive maintenance of the workflow, which is to understand if you need to scale up, scale down. It looks at also the WAPE and MAPE and RMSE, what based on the type of data you have to to produce the best solution for your DevOps scaling issues. So yeah, scale infrastructure automation across your infrastructure, not just like on-prem, but it can also do cloud and any other hybrid approach that you might have. This is AgentCast. Thank you very much for joining in, and I'm honored to present my AI agent, autonomous AI agent for forecasting to this elite group of people. Thank you very much.